We're continuing on with Unit 7. This is 7B. We're at the top of 94. Last section, 7A, we talked about multiplication rules for exponents, for powers. We had a couple different rules, and we did some work with those. It would stand to reason that now we're going to come up and we're going to look at the division exponent rules. So again, the explanation up at the top is just to show you what this looks like if you were going to expand it out on your own. X raised to the exponent of 5 divided by x squared. If you were going to stretch this out, it would look like this. X repeated 5 times as a factor. In the denominator, x repeated 2 times as a factor. And of course, you can cancel as long as it's the same top and bottom. That makes 1. Anything divided by itself is 1. And we can take that out of our problem. So we've got 2 opportunities to take a 1 out. And that leaves us with x to the third, x cubed, in the numerator. So the rule, if you don't want to stretch this out, which I'm sure you won't as the exponents get larger, there is a subtraction rule. And the rule says, take your base, and instead of adding the exponents like we did when we were multiplying, we're actually going to subtract them. So x to the 5 minus 2 is x cubed, and of course that goes back, I don't like that color, and matches your answer that we got when we actually did the expansion. So the opposite example would be if the power, if the exponent of 5 was in the denominator. Again, if we stretched it out and we took out our 1s, anything divided by himself, we would have still x cubed, but now the x cubed would be in the denominator. And what would we have in the numerator? The ghostly 1. Because everything, all of our factors are gone from the numerator, so we have to write the ghostly 1. So the rule is that, so this is the way Ms. Jett likes it explained, is that the exponent itself ends up on the heavy side. The heavy side actually means the larger exponent. So in this case, we had x squared divided by x to the 5th. We did the subtraction from the heavy side, 5 being larger than 2. So we put 1 over it. 1 over x cubed is your answer. So this is a good example of how it looks if your exponent is larger in the denominator than in the numerator. All right, we've got a few to do. So again, don't be confused when your base is a number. Treat it just like you do when it's a variable. So we've got the 6 is larger than the 2 for the exponent, so we're going to have 2 to the 6 minus 2 over 1, because 6 is heavier than 2. That ends up with 2 to the 4th power. And I think in the last video I told you you didn't have to go ahead and multiply that out. Well, I was wrong. So I found out she really does want you to go ahead and simplify this. So 2 to the 4th power is 16. And that's something you should just know. You should know your powers of 2 up through 2 to the 6th. 2 to the 5th is 32. 2 to the 6th is 64. These you use over and over and over and over again. So the sooner you commit that to memory, the faster it's going to go for you, and you won't make a mistake. All right, let's look at B. Again, 7, the bases are the same, x and x. 7 is larger, heavier than 4, so our answer is going to go in the numerator, and we have the ghostly 1 in the denominator, and x cubed is the answer. And of course, you don't have to write the denominator if it's 1. Move this up here. Now we're looking at the exact same example as B, except for now our exponent, the larger exponent, is in the denominator. So it's going to look like this, 1 over x to the 3rd. So these two guys are very different from each other. I'm not doing a good job being neat. All right, let's look at C. 5 is larger than 4. The bases are the same, so this is y to the 5 minus 4. It is over 1, but I'm not going to write that. And we're going to end up with y to the 1st power, or just y, as the answer. We're looking at D. 9, D, and the base is D, all D's in this problem. 9 is larger than 3, so my answer is going to end up down here, D to the 9 minus 3, which is 1 over D cubed. No, there should be a 3, sorry. 9 minus 3, 1 over D to the 6th. Let's look at E really quickly. Now we've got two variables. We've thrown in some M's and we've thrown in some N's. You can do them simultaneously, but the rule remains the same. So the M, if we look at it, the highest exponent is in the denominator, so that becomes M to the 5 minus 2. The N, the highest exponent, the larger, heavier exponent, is in the numerator. So now we clean it up. We have N to the first power over M cubed. I hope you guys think this is easy. I do. All right, moving along. Now this is the first one where we've actually got some coefficients, some factors that are numbers. And you need to go ahead and divide these. You need to treat these as if they're just numbers, because of course they are. So we've got 15, which is 5 times 3, and a 5 in the denominator. And then we have K to the 6 minus 1, because there's a ghostly exponent of 1 there. And then J, heavier side is in the denominator, to the 5 minus 2. So you can clean this up, and you end up with 3, because 5 goes into 15 3 times. 3 times K to the 5th in the numerator, and the denominator is J cubed. Let's run through, actually you guys go ahead and do G, and then we'll run through H together and call this video done. So I see a 2 and a 10. I'm not going to write out the factors because I know 2 goes into 10 5 times. So that's going to be the number portion of this. When I get to the variables, this is x to the 5 minus 4. 5 is heavier than 4. Let's take a look at the y's. The y's go down here, 5 minus 1. Don't forget the power or the exponent is ghostly 1 on y. And then z is in the numerator 8 minus 1. So that gives us x to the first power, z to the 7th power, all divided by 5y to the exponent of 4. And that's how these are done. See you next time.